Okay, so let's keep going. We're now going to solve problem 46. Find the surface area of the surface x equals z squared plus y that lies between the planes y equals 0, y equals 2, z equals 0, and z equals 2. Okay. So basically, we're going from, if this is x and this is z and this is y, we're going between y equals 0 and 2, those vertical planes, and z equals 0 and 2. Okay, so this might throw you off, right? Because our domain is no longer x and y, right? It's it's y and z, and our function is not it's not a function of x and y, and our function is x, and it's a function of y and z. So f, we have this, right? We have x equals f z y. Now, really, this is not too difficult. Well, we need to preserve. We can do this directly, but I want to show you a neat little trick. You just change the names. That's all they did. So let's just do it ourselves. So why don't we just shuffle things around? So I'm going to call what they call x, I'm going to call that z. Okay? So this is now z. But here's the deal. I need to preserve the right-hand coordinate system. So you remember at the very beginning, the right-hand coordinate system is the one that follows the right-hand rule. So you go from x to y to z. And what comes after z is x. So if x becomes z, then y has to become x, and z becomes y. Okay? So this is the old system, right? New system. Okay, so x, y, z, this will be z, y becomes x, z becomes y. And this is going to be really nice. Okay, this is going to be really nice. So I guess I should change the colors real quick. Let's see. So that should be y, z, and x. X, y, z. Okay, so now we have this new coordinate system. So if you just turn your head, if you just turn your head, you'll see that this is exactly the normal coordinate system. Now we're just going to go in and we're going to solve. We're going to mount a chair on the wall, and that's how we're going to solve this problem. No, we're not going to do that. We're going to go in and we're just going to change everything. Okay, so x becomes a z. Z becomes a y. Y becomes an x. Right. So y's become x's, and z's become y's. Okay, so that's all I did, and now I can turn everything. So just turn everything, and now you're back to a normal coordinate system, right? Though you could say it's the original one is going to be different, right? But the surface area, it doesn't matter, right? The surface area, if I look at it this way, or if I turn my head, it's the same surface area, right? Take a, right? So what's the surface area of this surface? Well, it's whatever it is. What is it now? Same thing, right? So that's the idea. Okay, so now that we did that, this is some surface, and those are some planes, and that's really easy to calculate, right? So we have a parameterization, r xy equals xy f of xy, where f of xy is just z, so f of xy. So now z really is a function of x and y, and we know what the surface area of this surface is, right? It's this integral over the domain. Well, x goes from 0 to 2, so dx, and dy goes from 0 to 2, right? And then the derivative of this, right? So the derivative of f with respect to x is 1, and with respect to y, it's 2y. So when I square this, I get 1. Square that, I get 4y squared, and then I have to add on the 1. Okay, so that's what I have. So in summary, I have this. If I factor out a 2, I have that, right? So all I did was add 1 and 1, I get 2, and then let's just check. 2 times 1 is 2, 2 times 2 is 4. So this is all correct. Now, I can pull this out. That square root of 2, I pull it out. And so now I have 1 plus the square root of 2y squared dx dy. Now, when you set up your integral, if you did it dy dx instead, that's fine. You just would have a hard time integrating that first one, right? Well, actually, no. We got to do that. So there's really no way around it. So when I integrate with respect to x, this is going to go from I pick up a x, and then I evaluate that, and that's going to go between 2 and 0, so I pick up a 2. So that'll be 2 square root of 2, 0 to 2, 1 plus 2y squared dy. And what is this? What is this? Well, I guess it's not that difficult, but it's escaping me at the moment, so I'll leave it to you.